Hey everyone. So let's start our lesson. I will share my screen now. So let's start with the topic who I am. I'm Alina. My surname is Andreeva, and I'm the software engineer in the EPAM. And today lesson will be held on me. The topic of our lesson is what is WebSocket. And if you first hearing the words like this, you can probably think that WebSockets are something like this, but I assure that it is not. Today I will tell you what is it, how it works, and where it can be used. So here is our agenda for today. We will discuss what is WebSocket. Then we will take a look at HTTP and WebSocket protocol. We will compare them. And after that, we will learn about the WebSocket API, its methods, events, and in the end, we will have a little bit practice. We will create the chat application using WebSockets. Do you hear me? Yeah, just check. Okay. What is WebSocket? WebSocket, it's a protocol that provides a way to exchange data between browser and server via persistent connection. The prime intention of the WebSocket protocol is to provide persistent real-time communication between the client and the server over a single TCP socket connection. Simply put, it is a permanent connection between the client and server, using which the client and server can send data to each other at any time. Some weeks ago, you had the lection about the HTTP, HTTP-C protocol, so you may know what is it and how it works. Now we will briefly have a little overview of it, and then we will compare with WebSocket. When we use the HTTP or HTTP-C, the browser constantly asks the server if there are some new messages for it and receives them. You may also know that HTTP allows different types of requests, such as post, get, put, delete, each of which has its own purpose, sends different headers to the servers. So let's look on the image to understand how it works. The communication between client and server is interactional, half-duplex. This means that if server wants to send information to the client, it cannot. Clients strictly have to make a request in order to receive a corresponding response. When request is done, the connection between client and server opens, but it is temporary and is closed as soon as a response from the server is received. And to create a new connection, we have to create one more request. And it's fine for the most of our everyday cases, and the majority of the internet today is on HTTP. But it doesn't do well when it comes to the high-load applications that deal with real-time data transfer. Sorry, 1 second. I apologize. Let's continue. So we stopped here. But it doesn't do well when it comes to high-load applications that deal with real-time data transferring, like gaming, trading, and not suitable for real-time full duplex communication. There are some workarounds that can do such functionality. Historically, creating web apps that needed real-time data require an abuse of HTTP protocol to establish bidirectional data transfer. When we have multiple, there we have multiple methods used for achieve real-time capabilities. But none of them were as efficient as WebSockets, HTTP polling, HTTP streaming, and server-sent events. Here you can see the small schemes, how they work. and also we will discuss it. First of all, it is HTTP long polling. The very first attempt to solve the problem was by polling the server at the regular intervals. The HTTP long polling life cycle is as follows. First of all, the client sends out the request and keeps waiting for the response. Then the server defers its response until there is a change, update, or timeout. The request stayed hanging until the server had something to return to the client. And when there is some change or update on the server end, it sends response back to the client. And after the client receives it, it sends a new long poll request to listen to the next set of changes. There were a lot of loopholes in the long polling, like header overhead, latency, timeouts, caching, and so on. The next method it is HTTP streaming. This mechanism saved the pain of the network's latency because the initial request is kept open indefinitely. The request is never terminated even after server pushes the data. The first three life cycles methods of HTTP streaming are the same, like in the polling. But when the response is sent back to the client, the request is never terminated. The server keeps the connection open and sends new updates whenever there is a change. And the last one, it is a server-side sent events. Client send response to the server, and server can send multiple responses to the client, called server events. A chat or gaming application cannot completely rely on server-sent events. It is sent over traditional HTTP and has restrictions on the number of open connections. These methods are not just inefficient, the code that went into them also made developers tired. The existing methods described before are not reliable and not efficient when it comes to real-time communication, and WebSockets are designed to replace them. WebSockets are similar to server-sent events, but they have a huge advantage because they can send messages back from the client to the server. Here we can see how the life were before the WebSocket. Here we can see that it is our client that sends responses, send requests to the server, and server needs to handle each of them. So let's move to the WebSocket protocol. The WebSocket protocol has only two agendas. The first one is to open up a handshake and to help the data transfer. The client establishes a connection by performing a process called Websocket Handshake. This process begins with the client sending a normal HTTP request to the server. Here we can see how the WebSocket connection can be opened. When we use the WS scheme, the connection is not encrypted, and the address port is used by default. When we use the WSS connection, the TLC encryption is required, and port 443 is used. The WSS is similar like we have HTTPS, if you know. And now let's take a look on how does the connection from the client side look. Here we can see an example of browser headers for HTTP request made by new WebSocket. This request includes an upgrade header that tells the server that the client wants to establish a WebSocket connection. Here we can see the origin. The origin is the client page, for example, example.com. WebSocket objects are not cross-origin by nature. They are no special headers or other limitations. Origin headers is important. It allows the server to decide whether to talk with the website. Then we can see an upgrade with WebSocket. It means that the requested protocol is WebSocket. The WebSocket key is a random browser-generated key for security, and WebSocket version is the version of the WebSocket protocol. The 13th is the current one. There may be additional headers like extensions and WebSocket protocol that describes extensions and sub-protocols. And now let's take a look at the connection from the server side. If the server supports the WebSocket protocol, it will agree to switch to it and will report it in the upgrade response header. Also, it should send code 101 in the response. If the code will be not this, the connection will be not established. Here we also can see the WebSocket accept and WebSocket key. They are recorded using a special algorithm. The browser uses it to make sure that the response corresponds to the request. After the connection is established, the server response will contain information about the transition to the WebSocket protocol. After the connection is established, the client can send messages to the server, and server can send messages to the client whenever they want. So the connection won't be closed until one of them decides disconnect. With WebSocket, you can send any amount of data without exposing the system to unnecessary load caused by the traditional HTTP requests. The data is transmitted over the WebSocket connection in the form of messages, each of which consists of one or more frames containing the data being sent. To ensure a proper assembly of the original message upon reaching the client, each frame is prefixed. The use of a frame-based messaging system helps to reduce the amount of overhead transmitted over the communication channel, which significantly reduces information transmission delays. The client only will be notified of the arrival of new message after all the frames have been received and the original payload of the message has been constructed. Now we can see the browser support of the WebSockets. So if you look at the picture, you can see that almost all the modern browsers support the WebSockets and even the Internet Explorer 10. Only Opera Mini doesn't support. And now we can conclude that there are pros of the WebSockets, and they are full-featured duplex stream, bidirectional communication protocol. Connection can be closed from either side, and WebSockets don't have cross-origin limitations. They are well supported in browsers. And here we can see where WebSockets can be used. It is social networks, feeds, chats, location-based services, online games, real-time updates like sport, marketplaces, finance, services based on real-time API. So it is everything that has to transfer the data in the real time. And now let's take a look at the API of the WebSockets. In the browser, WebSockets work only with the text or binary frames. Here you can see that we opened the connection, and you have seen this before. And here we can set the type of the data that we will pass. It can be text or binary frames. Binary format could be blob, array buffer, and something else. No settings required. Just send it in any format. But when we receive the data, the text always comes as string. And for binary data, we can choose between blob and array buffer formats. Socket binary type property is blob by default, so binary data comes as blob objects, but we can change it to array buffer. To get the connection state, additionally, there is a socket ready state property. It can have values null, it is connecting. So the connection has not been established. Then it is open, closing, and closed. I think it is clear. Once the socket is created, we should listen to events on it. There are totally 4 events. It is open, message, error, and close. And we can handle them and do some actions. There are only 2 methods for WebSockets. It is send and close. As we can see, the send method can send either text or binary data. And this is all from the theory. And now we can try how to use them. So for this, we will create not difficult web chat with the real data. So first of all, we will create the server, and then we will create the client. And then we will establish the communication between them. So let's start. Do you see my screen? Yeah. Everyone is muted, so it is so quiet here. So I prepared a little markup. It is here. 1 second, please. I will prepare everything. I open my HTML, and as you can see, here is some styling in style CSS, so our chat will be pretty. Now let's explore the code. So first of all, we have users. Here in this container with ID users, we later will display the active users. Then we have the messages container. Here we will add messages. Here will be our username. We will set a random username to the person that came. And here we have the form with ID input, where we will type the message and then we will send it with our form. The form also has its ID. And all these nodes are already found here. So you can see form, it is form input, username input, and messages wrap and users wrap. I also prepared a simple styling for the messages, for the notifications, and users and user. That will be shown here. Okay, let's start. First of all, we need to make npm init to init the project. I just click enter because I don't want to set up. So now we head to the package.json and we can install some modules. We will start with the creating of the server. For local web server, we use the library WS. It will allow us to create the WebSocket server. So I just copy what npm init ws. And one more library that I will be using, it is usability. Okay, now the libraries are ready and we can start to create our server. So to create our server, we use the WS library. We write WS require WS. Also, we need to add user ID library. We'll call it like this. So we need to create the port on which our server will be running. Port 3000, for example. And then we create our WebSocket server. For this, we use new WS server and pass our port to the options. Also, I will add a callback to see that the server is running. We will console log. On port. Okay, so now we created our server and we need to add a script to run it. We add start script and not go to the directory server and then choose the server.js file. Okay, let's check that our server works. We add npm scripts before. So reload. And now we received the message that our server is running. Great. After is running, we need to listen to the events. If you remember, we have events like open, message, close, send. So when WebSocket server we write on connection, it is the method of the library. And here we will receive WebSocket of the user that has connected. After the user connected, we need to set the unique ID to him. So we write const unique ID is equal of a function from the library unique ID. Also, we add the property to the WebSocket. So now our connection is checked and we can also listen to the message. So to listening of the message, we can write WS on message. It is our message event. And here we will receive our message. So now we will stop with the server and we will move to the creation of the client logic. I restart the server. And we go to the client. To create the WebSocket connection in the JavaScript, we use the native JavaScript with the function new WebSocket. So we write const WS is equal new WebSocket. And here we need to write the address of our WebSocket. It will be WS and localhost with our port 3000. Now we do the same logic of the opening on the client side. So we add WS on open. And here we can make some logic. For example, console log, I've connected. But we don't want to make so simple logic, so we will send the event to the server. We want to communicate with it. So how we can send the message? We use wsend. And if you remember, the send events can be only string or binary type. We will send the string. And to use it, we use the JSON stringify because we don't want a simple string. We want to send some object with data. We send, for example, event connection. The server knows that we have connected, and we will send our username. Here I write randomly name for the user. So as soon as the socket will be connected, we send this name. Hi, do you hear me? Sorry, my connection has lost. Do you hear me? Guys, everyone. You are right. And I don't see it. Okay, you are hear me. So as we discussed, we have our clients, and here it is our client, and here I connected to the WebSocket. I check it in the network, and it is step WS. When the connection is established, and this is our first message, event connection, and username is user with our name. Here, it is randomly generated name for the user. So our first message is sent, and now we need to handle it on the server side. So we handle it here, v on message, ws on message, and here will be our message. The message will be the string, so we need first of all to parse it. So we write parsed message is equal to JSON parse message. After we received the message, we want to check the type. We now have the event connection. So let's switch with event, first message event, and add some logic. Case it is connection. We'll add here later some logic. Also, we will have different events. It will be message event when user send a message in the form. And one more event, it will be user connected, but it will be later. So when the default one. And default, we will not do anything. So the message is sent to the client, and here we can see this message. So what we are doing next is, for example, console log. We take the username that we passed here. The chat. Now we will see this message here. Let's try. Yes, we see the message. User joined the chat and username is equal to this one. Let's try connect one more user. So another user with another ID. He also has joined the chat. Okay, great. What we are doing next? When the user has connected, we need to notify all the users that user has connected. And for this, we will first of all create the active users collection. It will be let active users go to empty array. Then we will create one more function. It will be user connected. Const user connected. Yeah, we will pass the user that has connected, and we will add him to our array. We will need this in future because when user disconnects, we need to remove it from the active users. Active users, push user. Okay. Then we will create one more function when user disconnected. It will be called user disconnected. Disconnected. And here we will pass the user ID. Now we will filter the users. And return only users that are not equal to this user that has left us. User ID, and we filter. And one more function that will help us in future, it will be getting the user by ID. We also will pass here the user ID, but instead we will return this user. Return active users, find. We also filter by going through the IDs and find the user that is equal to this ID. Okay, now all the preparation are done, and after the connection event has occurred, we need to add user to the active. we use function user connected. And here we need to pass our user. But now we have only his username, and we will also create the unique ID for him. So our object will be ID with unique ID and username. Username. So the user will be added to our collection, and we need to notify the users that user connected. If you remember, for sending the messages, we use WS send. But if we use here WS send, we will send this message only to the user that has connected. But we need to send this message to everyone that is active. So we create another function that will be called broadcast message. Broadcast message is equal to, here we will send message over, and to get each active client, we use the WebSocket server property clients. And going through them, and we use each client and send message to him. Message. Now we will send message to everyone. Just use this function here. And we need to pass our message. What will be the message? The message will be also the string. So we need to use JSON stringify. And here is our object. The type of our message will be, for example, notification. Later we will have another types like message and active users. Type notification, and the message will be this one in the chat. Okay. Also, we will send one more notification to the client, but the type will be another, active users. When somebody has joined, we also need to show all the users here. So we send this event. We remove this. And the message will be our array. So we simply put active users here in the format of string. So now we had all the notifications, and let's reload the server. So server is running. The user is connected. And what is next? We need to handle all these events on the client side. So first of all, we will handle the notification. How we can listen to the message? We use WS on message call function, and the message will come here in the data. So our message will be here. To get the properties from the message, we also use JSON parse because now it is the string. We will use destruction here to get the properties directly. We have type and message. Here, type and message. So we can get it from this object. JSON parse data. Then we go through the types because we know that we had already created some types: notification and active users. We switch the type and case it notification. Here we will add the function later for the notification. The same will be for the active that we created here. And one more type that we will have, it is the simple message. And for all these events, we will add logic later. Hi, do you hear me? My connection crazy today. Oh, guys, let me know, please, something that you hear me. Do you hear me? Hey, do you hear me, guys? Sorry, my connection is crazy today. No. Do you hear me?
Yes, we do.
Oh, okay. Could you please tell me where my connection was lost? was lost? At which moment? Okay, let's proceed with this. So we created the notification and we created active users. And now we switch the type to handle these events. So we create the function for the notification. It will be called add notification. I already have the markup for the notification. It will be like this. So now I create a function. And here I need to pass the message. And also I need to know where to render this message. So I will also add the wrapper. Okay, we have the message and wrapper and need to pass it here. The message will be our message, and the wrapper where we will render it, it will be our messages wrap. It is the node with ID messages that we found here. Okay, now let's set the logic. First of all, we need to add the div to create the div with document create element. Then we need to add class name to this notification. We copy this one class name, and then we need to add some content of our message. Notification inner HTML is equal to our message. And we add this markup to our wrapper. And child notification. Great, now we have our function. So let's restart the server and try watch what happened. I can open, close this, and reload. So now you can see that we received the message. Here, the user joined the chat. And here you can see it. The red arrow means that the server sends it to us. And the green line means that we send. And we send and server sent. Also, we have another type, active users. So we need to also create a function for it. So when the user will be added, we can add it here. For this, we will create the function with name, for example, update active users. Update active users. Here we need to pass the message. It will be our array of users and wrapper, but the wrapper will be another users wrap. Okay, great. Let's create another function. Oh, it is incorrect naming. Update users. Our message now is the array, is a string, and we need to parse it to array. So we use const equal to JSON stringify. Oh, JSON parse, sorry. Now we received the array of users. For the users, we have this line that has styling. So we need to add this for each user. So we need to change a little bit our logic. So first of all, we create the markup that equals to empty string. And after that, we will go through each user and add his markup to this variable. So now we use for each user. And for each user, I will add the markup with this one. We need to get the username from our object of user. As you remember, we have ID and username, so we display the username. And after all the users were added to our string, we need to add this node to the wrapper. So we use wrapper in HTML is equal to markup. Update users, update user. Okay, let's try. Oh, we see that now there are 2 users here. And now we see 3 users with the names. Why we see 3 users? Because when user disconnected, we don't have an event for this, and we also need to handle this event and remove user from active after this happens. Let's try to implement this logic. We go to the server and hey, do you hear me? Guys, I've lost you. Hey, do you hear me? Hey, do you hear me? Oh, I hear you. I don't know what happened. It is hit maybe. So, as I said, we need to handle the disconnect when user is disconnected. So when user is disconnected, we can catch it with the event on close. WS on close. What I'm writing. Function. And here we will need our user. So we created the function for this to define what user has disconnected, to know his name. So the user is disconnected. Selected user. Get user by ID. And our ID will be the ID of the socket that we set here. So we use WSID. And after the user disconnected, we need to notify all our clients that user disconnected. So we just copy these two functions. Instead of has joined, we write has disconnected. And instead of parsed message, we use selected user. Username has disconnected. And also we need to update the active users. So we send a new array. And of course, we need to disconnect him. Earlier, we also created the function user disconnected. We send user ID, and we see that it will return us the new array without this user. Okay, it is done from the server side. Let's check. Now we will see the message here, I suppose. Yes, we see the message, the user disconnected. And we see the new active users. Okay, let's implement this here on our UI. It is already implemented. So it is the same types, add notification and add active users. So now we see what users are here and what users left us. Let's see, we have 3 users. One user has disconnected and another user has disconnected. Great. I reload the page to clear the chat. And the last functionality that we need to implement, it is the sending the messages to each user. So let's start. We need to add event on this form. So we have the form node. We use form add event listener, and it will be submit. We get the event, and then we write event prevent default because we don't want the page be reloaded. Prevent default. And after the submit, we need to get the message from here and to send it to the server. So we write the next ws send, and here we use JSON stringify as usual, and our object. We have the events here, so we copy them, and instead of connection, it will be event message. The username is the same, and also we will pass some new properties. It will be a message, of course, message from here. We have the input or not, it is this one, and we just set input value. And let's pass also the time of the message, as it is usual in the social networks. Time will be new date, local time string. So we send the message to the server, and now we catch this message here. We have event type message, and we make the next. We need to send also to all the clients our message. So we use this function broadcast, but instead of type notification, we will change it to the message. And the message needs to have all the properties of this message. Username, message, time, so we can simply use spread operator and then we will get the next message. Let's try. I want to show you what we have. You can see here that we received type message, event message, username with our username, and message hello, and also we received the time. Okay, let's show this on our UI. We create one more function. Let's copy this one. It will be function with name add message. Here we pass our message, our wrapper. Also, we need our username that we can get from here. And time. And one more thing that I want to know, if it is my message. It will be the Boolean value. If it will be my message, I will show it here. If it is not my message, I will show it there. I can simply understand if it is my with the username is equal to username input value. It is my input, it is my name, and I check. And now we will write the function. It will be a little bit similar to the add notification because we use the same wrapper. So now we have more properties. This username, time, and is my message. And after that, we create the message item. Then we add class name from here. So the logic is the next. If it is my message, I add additional class name. If not, I don't add. So is my message. We write the condition here. In other case, class name. Okay, and after I created the user, after I created a message item, I need to add this markup inside of it. So I add copy everything. And here I need to replace message with the string. So I have the username and I add username. I have the time and I add time. And after that message. And push this message item to our wrapper. Okay, let's try. No, it doesn't work. Let's reload. I reload the page and say hello. Submit the form. And nothing happened. Time is not defined. Where is time hour? Time is, of course, time is not defined. We haven't mentioned it. So let's try again. Hello. Oh, and message has appeared. So let's add some more users to check it. So we see that users has joined the chat and they want to welcome. We see that the username is the same, like in the bottom, and the time we see, and the message. So from the first user, I see this message like it is not mine. And here I can answer. So everything has appeared, and the third user. Hi everyone. I'm new. And everyone received this message. So we have created a part of the social network in 1 hour. Okay, I think it is it. If you have any questions, let's ask me. I will add later the code to the repository and will add the link to our spreadsheet. Also, recording will be available. So, guys, do you want to talk with me or not? I see we don't have any questions. Everything is clear. Yeah, of course. Yeah, I will do it today or maybe tomorrow. Okay, thank you for the participation and hope you will join your first job very soon. Thank you. Thank you. Okay, bye for now and have a good weekend.